So this is unit 2. So we're adding on to unit 1 that we did last week. The first page is called unit 2A if you're aligning it with like the AP classroom progress, stuff like that. So it starts with arithmetic and geometric sequences. If we remember, arithmetic means that you're adding, oops, that was way too big. You're adding the same thing each time. Which means, and that thing we call the common difference, and that is D. This means it is also linear, okay? So linear and arithmetic are the same thing. So if it says something is arithmetic, you can make it linear, meaning I can take my arithmetic sequence term, which is an equals a1 plus d times n minus 1, and I can also change that into slope-intercept form. So I could take something that, if they give you two terms in your linear or in your arithmetic sequence, I can also just make them 2 coordinate points and put it into point slope, because arithmetic would be the same thing as linear. Yeah. I still have one more makeup to give. Yeah. All right. So then let's say it gives you in this equation, A1 is your first or initial term is what it's called. And we know D is the common difference. The difference between linear and arithmetic is that a linear is literally a line, whereas arithmetic is a series of dots. So if I were to look at a graph and it had said like which of these represents arithmetic and which of these represents a linear function, then the linear is going to be a line. And arithmetic would be a series of dots. Other than that, they can kind of be treated the same. So again, if I said like you have arithmetic sequence and A1 is 5 and A2 equals 10, this is the same as saying 1, 5 and 2, 10. And if it wants a function, you could literally just plug it in a point slope. So you could plug it into your linear, your arithmetic sequence, but I think it's easier to make it linear.
Does arithmetic have arrows like linear?
No, arithmetic would be dots. That's what, like on the right-hand side, just dots. Yep. Yeah.
Do you have the charger?
Yeah. All right, then we had geometric, and this is multiplying by the same thing each time. Okay, and that thing is your R, which is common ratio. This one is an equals a1 times r to the n minus 1. And this was your big little scenario. So we talked about this a little bit last week in the FRQ. If you don't have sequential terms, then you would do a of the bigger base equals a of the smaller base times r to the big minus small. And this is the same almost as exponential. God bless you. So I actually, if I'm choosing between geometric and exponential, I make my exponential geometric because I think it's easier if you don't have a calculator to do that big minus little. So in this case, if I had A1 was 5 and I had A3 was 15, well, let's just make something up, 15, then I would do A3 equals A1 R squared. So I'd get 15 equals 5, God bless you, times R to the second. And then I would divide by 5 and then I would square root it. Which is here I would do y2 minus y1 over x2 minus x1. So So when choosing between arithmetic and linear, I pick linear. You don't have to, but I would recommend picking linear. And when choosing between geometric and exponential, I pick geometric. And just like with arithmetic and linear, the difference between exponential and geometric is that geometric is going to have a curve. I'm sorry, exponential is going to have a curve, whereas geometric would be a series of dots. In 2A was where we talked about inverses. So there was a bunch of different ways to do the inverses. One, the inverse notation is the -1. So it would say f of x to the -1 like that. No, it would say f of -1 of x, sorry. That's how we know it's talking about its inverse. So anytime it was a -x, it could be on f of x, it could be on a trig function, whatever it is, that little -1 means what's the inverse, right? And for inverses, we switch the x and the y. If it's an equation, we literally switch the variables, we solve for the new y. If it's coordinate points, we switch the x's and the y. If you're talking domain and range, you would switch your domain and range, okay? All of those things, we just switch the x's and y's. And then we use the horizontal line test to determine if it has one. But we talked about this last week with the FRQ. If it does not have a if it fails the horizontal line test and it asks you to describe why, you cannot say it doesn't have an inverse because it fails the horizontal line test. What you can say is it's not one-to-one. Function is not one-to-one, which is definitely the easier option of what I'm about to write. Or the input values must be mapped to unique output values, which means the y cannot repeat. Two equations in this section, which were continuous growth and double rate. We also did like half rate, but these are the more common ones. So continuous growth is PERT. A equals P times e to the RT. So if something has continuous growth, P is your initial amount. R is the rate in decimal. So if it's in percent, we have to move it back. T is the time. And then your double rate would say, like, how long does it take to double? Or for this amount, it takes this many years to double. And so that is f of x equals the initial times 2 raised to the t over n. T is the time, n is the time it takes to double. So if it said your, whatever, the population will double in 3 years, then n is 3. No, time is like how many years is it in there, and n is how many years it would take to double. And if it said half, it would be the exact same thing, but it would be half in the inside. So how many, like that's your half-life.
So half life would be P times 1/2?
Correct. To the t over n. Okay, exponential growth versus decay. So exponential growth is increasing as you move from left to right. Decay is decreasing as you move from left to right. For growth, your A is greater than 0 and your B is greater than 1. Or your A is less than 0 and your B is less than 1. So if it starts as a fraction that's raised to a negative number, it flips it, so it makes it growth. If it starts as a whole number raised to a positive value, bigger than 1, then there's growth. This is decay. Okay, if it's decay, then A is greater than 0, but B is less than 1. No, sorry, A is greater than 0, B is less than 1, or A is less than 0, and B is less than 1. No, greater than 1. So if you start off with a whole number, and your exponent is a fraction, it's going to get smaller, so it's going to fall as it goes. If you start off with a negative number, or something less than 1, with an exponent bigger than 1, then it's going to fall. All right, now we move into logs. Yeah, 2, because it takes a double, right? It's 2 times the amount. Yep, okay, log properties. So this, we're talking expansion, and we're talking condensing, and we're talking logs and also ln's. Like every rule that applies to a log also applies to an ln, because ln is log base e, okay? So first is log equals log base 10, and ln equals log base e. Those things you have to know. Then you've got your product, your quotient, and your power properties. So log of A times B would equal log of A plus log of B. When we multiply, it becomes addition. And we can go both ways with this. Like you could condense or you could expand. If it's log of A over B, this becomes log of A minus log of B. Again, oh, I missed my G. Log of B. Again, this equals, and it can go in both directions. And then the third one is the power property. So log of A raised to the B. That B gets bumped to the front. B log of A. So these show up a lot in FRQs. It will give you this as one of your functions. Like it might give you a log as a function. It might give you a trig function as one of your functions. It might give you an exponential. Like it's going to give you, here's f of x, g of x, h of s, like that. And then one of your I steps, like I or II, will say condense it to one log or rewrite the expression in terms of one log. Or if it starts as one log, it will say rewrite the expression as a sum or difference. And then that means expand it out, okay? That is probably going to show up in one of your FRQs. Then we got to graph of logs. These are in the shape of your R's. So we talked about this a little bit last week because it came up in that FRQ. But a log is in the shape of that little like arc, like a square root that doesn't end. You'd have to know how to use your transformations. So f of x equals a, let's do plus and minus, log bx minus c, close it, plus or minus d. All the transformation options, so same as all the other functions, right? Everything that happens outside the parentheses is affecting your vertical. Everything that happens inside the parentheses is affecting your horizontal. God bless you. So the plus or minus at the front is your reflection, right? If it's positive, it has your typical shape. If it's negative, it flips upside down to form almost like an L. The A would be your vertical dilation by a factor of A. That's a terrible color. Can you read that?
Vertical dilation by a factor.
Yeah, okay. Then D, the last thing that affects vertical, D is a shift up or down. Up if it's a positive D, down if it's a negative D. So that stuff would affect your vertical, your range, stuff like that. All the things that have to do with a vertical shift. And then the inside is your horizontal. So the B is a horizontal dilation. factor of 1 over b. If that one was positive and negative, so if there's a plus and minus here, that positive is normal, negative is a reflection over the y-axis, so it points it left. And then C, and that negative could be on the B, it could also be on the X, anywhere like that. The C is a horizontal shift. A positive C means left. A negative C means right. And the way we would describe this guy is a reflection over the x-axis. This actually, you can move that to transformations because it's true about a log or any other function. So when you're graphing logs, typically you can use your transformations and just slide it around. But you also, if you needed to find an exact graph, you would switch the x and the y. You would convert to exponential. And you would plug in for y. So exact graphs. If the transformations did not work, or you didn't know what they look like, or you questioned it, that's what you would do. The pink is if the B or the X is positive, is negative, it flips it over the y-axis. It's a reflection over the y-axis.
Oh, right.
Yeah.
And what is the arrow in the parentheses?
You can either have it on the B or on the X. So if there's a negative on the front or there's a negative on the X, both of those would flip it over the y-axis. Yep. 2 things that you could check for with your graphs to find the y-intercept. We plug 0 in for x. Wait, is it? No, it's going to ask for the x-intercept on this one, sorry. X-intercept, as always, we plug 0 in for y. And your vertical asymptote, we set the bx minus c equal to 0. So if there's nothing in parentheses, then you have a vertical asymptote at 0. But if there is a horizontal shift, it moves that vertical asymptote, which will also impact your domain. Yep.
What is
Like I just put a dash there. The vertical intercept, that one. Yeah. I mean the x-intercept. You plug 0 in for y. And then the vertical asymptote is VA. So the transformations are exactly the same, except that it's going to say f of x, or actually usually says g of x. G of x equals, and it would be a f of, and then it builds inside. Like that. That's when you have no idea what your parent function looks like, right? Which is usually how a multiple choice question will give it to you. It's going to give you you have no idea what the parent function looks like, but you have some sort of shift happening there, and it will literally say describe the transformation. So is it a vertical shift? Is it a horizontal shift? Is it a reflection over the y-axis? Those kinds of things, just based on the letter F, not x squared or square root or anything like that.
If, for example, if it's a question with like the parentheses like expanded out.
Usually they have it like this. Should it be distributed, you have to take it out to figure out what C is. So it doesn't change the B, but if it says A, F, B, X minus a number, now in order to figure out your horizontal shift, you actually have to take that B out. Yeah, but typically it gives it to you with the parentheses. All right, then exponential and logs from a chart, meaning it's going to give you an input. God bless you. It's going to give you an output, and it literally gives you data, okay? So how do you identify if it's a log or exponential from a chart, or if it asks you to describe it? Exponential is as input values change additively, output values change multiplicatively.
Is that output below input?
Output is below input. Yeah, input is your X, output is your Y. And then the reverse is true for log. Log as input values change multiplicatively. Output values change additively. So exponential would look like the numbers 1, 2, 3, and it could be 4, 16, 64. So as your input values increase or decrease additively, because it could be both, your output values change multiplicatively, whereas the log would be the reverse. It'd be 1, 2, 3 for your Y, and 4, 16, 64 for your X.
What is log add?
Like log would be like you would, it would be that you would, if it said which one is it, exponential or log, you would say it's log because as input. Does that make sense? Okay. No, it's okay. What I write doesn't always make sense when you read it later. Everybody still good? Okay, I'll do change of base since it's under it. Change of base means if it says log base A of B, this can be written as log of B over log of A, or ln of B over ln of A. It is the larger number by like physical size, like when you write it, not value. So if it said log of 12, log base 12 of 5, this would be log of 5 over log of 12. That would be a ratio of common logs. Or it could be log of 5 over, no, sorry, ln of 5. Why the dots? ln of 5 over ln of 12. That would be ratio of natural logs. All right, log equations. So also something that could be on multiple choice and built into your FRQ as one of the parts. So let's say it had said expand or condense, then it could say find the values where f of x equals 10, and now you're actually solving these equations, okay? So there are a bunch of different types of logs, or log equations. The first is if there's only one log. On one side of the equation. So if it said log of x equals 2, for example, then I convert it to exponential. So what would be the base on that log? 10. This would be 10, and then I would change this to 10 to the second equals x, so x equals 100. Something like that.
It's always 10 when there's no number.
If there's no number there, yep. And it would be e if not.
E if they gave it to you.
I mean e if it's ln. If it's ln, it's e. Sorry. All right, then what if it's one log on either side? So this could be ln of x plus 2 equals ln of 10. That's if it would be, if this would be ln of x equals 2, I would change that to log base e, and then the e would pick up the 2. But if there's one log on either side, we use what it's called the one-to-one property, right? One-to-one says literally ignore the ln and set it equal to each other. So drop the log or the ln and solve. If there is multiple logs on either side, you're going to first condense, then solve. So this could be like ln of x plus ln of 3 equals 2. And so I would condense the ln, it's addition, so this would become multiplication. This would become ln of 3x equals 2. And then there might be a log still on either side of the equal sign. If there's a log on either, I drop the logs, I solve. Or it could be exponential, in which this e is going to come over and pick up the 2. And then I would, in my calculator, e to the second, and then divide it by 3. If you had a calculator, you could also type this side of your equation into the y1 and this side of the equation into the y2 and see where they cross. The most important things on these is you have to check all log answers. If when you take that answer, you plug it back in, you are finding the log of a negative number, you cannot keep it. Or log of 0. So if I had like ln of x equals whatever 10, obviously this would not be my answer. But if I got the answer that x equals 0, I cannot keep it. Or if I got the x equals a negative number, I cannot keep it. So that usually happens if there's more than one answer. We rule some out. Any log equation that you solve for and you get x equals, you have to check to make sure it could get plugged back in. So you plug it back into whatever's next to the log. So whatever's in here, when I plug the answer back in, I don't have to go all the way through and find the answer, but I have to make sure that whenever I plug it back into next to that log, what's inside the parentheses is not negative or 0. If it is, I rule out the answer. Yep. All right, last thing is a semi-log plot. This was the one that had a regular x-axis, so these are going up in increments by 1s or 2s or whatever it is. But my vertical axis goes up by powers of 10. So it started with 10, then it jumps to 100, then it goes to 1,000, then it goes to 10,000. That is a semi-log plot. Huh? Yeah, hang on, let me finish this and I'll go back to it. And then the rule is if an exponential graph or exponential function is plotted on a semi-log graph, the graph looks linear. So this is like you got multiple choice questions and it said which of the following would be linear, would represent a linear function. I mean an exponential function, okay? And if you're looking at semi-log plots and you're looking at the semi-log plot, that literally looks at linear. So it would have dots like that. If it's linear, if the graph of a semi-log plot is linear, that means the initial data was exponential. Yep. There's an assignment. If you could please just submit that page. So what are we on, page 3 and 4? If you could send to Canvas just pages 3 and 4, it would make my life easier. When I'm in a better mood, your grades are higher. Yeah. Where? What? All the way out?